Everyone wants to be more productive, from the principles of lean manufacturing to shaving seconds off machine cycle times, and programming is no different. This tutorial will cover some of the productivity tips that will save you time when programming your parts in Fusion 360. For the first tip, let's edit this 2D contour operation that is finishing the outer contour of this bracket. In the Passes tab, you can see that we have enabled multiple depths to split the toolpath into several step-downs. While hard-coding 250 thou will work, it will always be that value even if there's a change to the tool. So instead of simply typing in a value into the step-down, I can right-click and select Edit Expression. This displays a new dialog, which allows me to use tool or operation parameters, as well as combine these parameters with mathematical functions, such as min and max. So let's set the step-down equal to 80% of the tool flute length. This will ensure we don't rub on the shank of the tool against the part, while still maximizing the tool's cutting potential. To help define expressions, as you start typing parameters, an autocomplete dialog is displayed to help you find the right parameter. Once you press OK, the numeric value of your expression is displayed. Expressions capture your programming intent, so if I change the tool, in this case a 1/2 inch diameter flat end mill, the step-down value will automatically update to 0.96 inch for this tool. Now, once you have all your parameters dialed in, you can also set defaults for individual parameters or the entire toolpath. In this case, if I right-click on the step-down and make default, all future 2D contour operations will have a step-down that is 80% of the tool flute length. If I make all default, all parameters will be made default for this operation. If for any reason you want to return to the original default, reset to built-in default will return to the factory setting. Finally, Fusion 360 allows you to import and export default parameters, so you can quickly share best practices within your shop. Next up, patterns. Patterns quickly duplicate toolpaths within a single part or across multiple parts, like we have in this tombstone. To create a pattern, we need to select the toolpaths we want to be included in the pattern, right-click, and select Add to New Pattern. The first pattern is linear, which creates a linear array using directions selected graphically using the model, sketch, or work geometry, a manual spacing parameter to define separation, and the number of instances. The final parameter on the Pattern tab is Operation Order, which allows us to specify whether we want to order the toolpaths by tool, which will minimize tool changes, by operation, which will machine all instances of a particular operation before moving on to the next toolpath, or preserve order, so machine operations in each instance of the pattern before moving on to the next. Now let's change the pattern type to circular and define the rotational center for the pattern as the model origin z-axis. With an angle of 360 degrees and 2 instances, you can see that we have successfully programmed one of the parts on the reverse of our tombstone. If we change the pattern type to mirror, we need to define the mirror plane. We can use the XZ plane of this model origin, and once again we have programmed a component on the other side of the tombstone. Note that this will also create a mirror of the original, so this is useful for left and right parts. Also note that the toolpath direction is also mirrored, so if the original toolpath is climb cutting, the mirrored toolpath will be conventional cutting. To prevent this, duplicate all the toolpaths you want to mirror and add them to a mirror pattern where you uncheck Keep Original. Change the toolpaths in that pattern to be conventional cutting. Compare and edit could be used to speed up this process. Now the pattern toolpaths will climb mill as desired. A duplication pattern allows you to use geometry to pattern the selected toolpaths. First, select a source point from the original model. Now we can set the target points. As we have multiple models positioned in our tombstone, we can select the same point on the target models. We don't have the ability to specify any rotations with the duplication pattern, so both the original and target model need to share the same orientation. The last type of pattern is a component pattern, which is going to allow us to specify a source component, and it will automatically apply the specified toolpaths to all instances of the selected component in our assembly, this time adjusting for different orientations. If you only want to apply it to certain instances, you can deactivate automatic and manually select components. The Post-Process tab allows us to override the work coordinate system offset from what we specified in the setup if needed. Next, toolpath templates help streamline the programming process by storing a group of toolpaths that you can apply later on, capturing not only your intent, but a full process. To create a template, I'll select the operations I want to include, right-click, and store as template. Give the template a descriptive name, and it is automatically stored in your Cloud Template library if you enabled Cloud Libraries, which we covered in the tour of the user interface. Back at the torque plate, we can right-click on the setup, create from template, and choose the template we just saved. Toolpaths that don't rely on selections will regenerate successfully, while those that need contour selections will need to be edited. However, all other customizations have been saved in the template, so even if a small amount of reselection is needed, plenty of time was saved by capturing my process in the toolpath template. If I do want to make any changes to my toolpath, such as changing the tool, they are still fully customizable. If you always find yourself using the same toolpaths on every part with the same toolpath settings and options, templates are a great way to save time programming. Now that we're ready to create some code, the final tip is NC programs. NC programs are an alternative to the post-process option and offer several benefits, including robust post-selection, clear post-property settings, grouping toolpaths from multiple setups, and transparent toolpath ordering. In the Settings tab, I'll set the program name, comment, and choose a local output folder. When selecting a post, I search for my desired post from the list of over 100 pre-installed posts, browse to a personal post, or I can even choose to download one from the free library of online post processors. The Properties tab displays post properties for the post I have selected, so it keeps the page clean and easy to understand. Post property selection are sticky even when program changes are made, or the design is opened and closed. Lastly, we have the Operations tab, which is where I can select the toolpaths to include in this NC program. For this one, I want to output every toolpath from both the bracket and torque plate setups. When I check Minimize Tool Changes, the operation order changes to improve our machining efficiency and our overall productivity, and the list updates visually to clearly show me the updated order. The NC program appears in the browser, and I can rename it for clarity. By right-clicking, I can also perform a simulation, which simulates the operation in their new optimized order. We can also create a setup sheet, which saves a PDF file directly in the data management console and is directly linked to our design. Lastly, we can choose to post-process our NC program, which automatically creates a G-code file in the output location with these settings and operation order applied. If we make any changes to any of our operations, there is no need to recreate the NC program. We simply need to repost the code. So if I change the tool for the outer finishing toolpath to 1/4 inch, you can see that the NC program is automatically updated, and the operation order reflects this tool change.